Hello, ladies and gentlemen. This is Mr. Arias. In this video, I'm actually going to explain how to factor a trinomial in which the leading coefficient for the quadratic term is any value bigger than 1. So, for example, if you notice, in this case, my trinomial has a value of a that is positive 2. However, technically speaking, we can always use the same method which was introduced in class last time, and this is the box method. So I'm going to draw the box, which will be on the right-hand side. And then I'm going to be following the steps that we have on the left. So if you notice, step 1 says that we have to factor the quadratic term, which in this case is the 2x to the power of 2 in my trinomial. So I'm going to highlight this in the meantime. And then the second step, just to quickly go over that, is to do the same thing. We have to factor, but now what we have to factor will be the constant, which in my trinomial is positive 2. So as a reminder, just so you know, anytime that you use the box method to factor, we have to place the quadratic term inside the top left entry in the box, and then the constant in the bottom right. So what that means is that my 2x to the power of 2 will be landing here in this position, and the positive 2 will be in this one across this box. Also, just to keep in mind, these terms are going to be, in these entries are going to be invisible for now, but then eventually, as we find the factors of the quadratic term and the constant term, we're going to find out what those values will be. So that being said, let's begin the process. So step 1 is basically to find the factors of 2x to the power of 2. And what's going to happen is that we have to find the factors that when you multiply those two factors, they would produce 2x to the power of 2. There's pretty much only one combination that we can have right here, and that would be just 2x times 1x. Because if I multiply 2x times 1x, we get this top left entry. Okay, so that's that. Then I'm going to put a plus here and here just for separation purposes. Excuse me. And now the next step is to factor the constant term. So the constant in this case is positive 2. So I have to find the two factors that if I multiply them, they would produce this positive 2. And again, after doing some quick evaluation in our head, we know that the only combination that produces 2 at this moment is 1 times 2. So that being said, I have found this now this binomial across the base and the height of my box, and those will most likely be the factors. However, we have to check our work, which is the last step of this process. So we have step 1, step 2, and then lastly, we have to check our work. So the work check is going to happen after we find out these entries in the diagonal directions in the box. And for that to happen, you can simply multiply the x from the height by the 2 from the base to then produce this term up here. So this is the answer when you get when you do the multiplication of x times 2. And then in the same way, if I multiply this 2x times 1, we're going to get 2x, right? Okay. And then eventually, if you notice, these two are going to be like terms. So what happens if you add 2x plus 2x? We get 4x, right? And if I take all the terms out of this box, what would happen is that we have the following trinomial. We have 2x to the power of 2, and then plus 4x, and then plus 2. Now, take a moment, ladies and gentlemen, and see if anything is missing or something doesn't make sense. Okay, so I'm hoping you had a chance to check it out. But technically speaking, we have a little problem down here. Because if you notice, this trinomial that we get by putting all the terms from inside the box outside doesn't match the original problem. This middle term is a 4x as opposed to a 5x, which basically means that something happened along the way. So if this happens to you, before you erase any work on the box, my recommendation is to change the position of the factors of either 2x to the power of 2 or 2. Just maybe swap them across the base and the height and see if that fixes the problem. Now, for example, let's quickly fix it or try to fix it by, let's say, by switching these two from the base and these two from the height So what's going to happen is that those two are going to switch position, right? So now this becomes a 2 and this becomes a 1. And then after this, what would happen is that I'm not going to have these terms anymore in these diagonal entries, because now my x from the height is multiplied 1, right? And then 1 times x is equal to 1x. So that'll be my next answer, my new answer actually. And then if I multiply the 2x from the base by the 2 from the height, we get 4x. So now if you add x plus 4x, we do get 5x, which is the answer that was expected initially. Okay, so just a little tweak, like a little twist of the problem for you to know what could happen potentially. However, it's an easy fix if you just play around with the positions of the factors. Do not erase all the work because you might need it still. It's potentially an easy fix that you have to just pay attention to. Okay, so, and this is how we finally check our work. So this answer makes sense. Okay, so that is one of the examples. So, and also, by the way, the final answer is the following. So keep in mind that the final answer is just the product of those two binomials that we get along the base and the height. So my final answers will be 2x plus 1 times x plus 2. So these are the binomials that if I multiply them with each other, they would produce the following trinomial that we originally had in this problem. Okay? So that's example 1. Let's do another example, just in case. So for the next example, I'll just take this off right here. And then this. I'm going to recycle the box, but I'm going to take off the terms that, that we had inside and along the base and the height. Okay, so for my next example, we have now the following trinomial. So please copy it down. So now the next trinomial will be, so we have 4x to the power of 2, 4x to the power of 2, and then plus 6x, and then we have plus 2. Okay, so that's the second example. For this example, we have to apply the same steps that we had in the previous example. So step 1 is to factor the quadratic term, which in this case is 4x to the power of 2, like I said. I'm going to circle it. And then the second step is to factor the constant, which is again positive 2. So like I said, I have to place my quadratic term in the top left entry, and then the other constant now will be in the bottom right. Now we just apply the steps one at a time. If I want to factor the quadratic term, I'm basically asking myself, what two terms can I multiply by each other to produce 4x to the power of 2? So in this situation, I will say you can basically think about it for a moment and play with different combinations. So for example, if you multiply 2x times 2x, that produces 4x to the power of 2. However, you can also multiply 4x times 1x, and that will also be 4x to the power of 2. So my take on this situation is just take a random option of combination of these factors and see if that works out. If it doesn't work out, you can just play the little trick that I taught in the previous example, which is switch the positions of the factors across the base and the height. And if that doesn't work, this is when you might have to come back and play with another combination of these factors. So for now, I'm actually going to use the bottom one right here, which is for x times x, and we'll see if that could be a potential factorization. Okay, so I'm going to place my 4x across the base and my 1x across the height. And then if you check it, if you multiply 4x times x, that produces 4x to the power of 2. So check mark, that's good. And now we have to just find the factors of 2, which again, we found them in the previous example. They are pretty simple. They are just the 1 times 2, right? So we have step 1, step 2 out of the way. Now all we have to do is fill out the table and then check our work. So if I multiply the 1x from the height by the 2 from the base, we get 2x. And if we multiply 4x from the base by 1 from the height, we get 4x, right? So now eventually, if you notice, these two terms are going to be like terms. So if I place all the terms outside of the box, I get the following expression. So I'm gonna get 4x to the power of 2, and then we get this positive 2 at the end, and then in the middle we have plus 2x and then plus 4x. So at this moment, we really realize that we have like terms. We have 2x plus 4x. This is a little bad. There you go. And then they add up to become 6x. So pretty much my final trinomial, if I were to put all the expression outside, is 4x to the power of 2 plus 6x. Excuse me, that's supposed to be 6x. 6x and then plus 2. So this actually matches the trinomial that we had initially in the problem. However, ladies and gentlemen, this is not the final answer. The final answer, again, is, since we're factoring, the binomials that we come up with after finishing the factorization process. And that would be 4x plus 2, so parentheses 4x plus 2 times x, or 1x plus 1. And that's it. So this is how you apply factoring using the box method when the leading coefficient of the quadratic term is anything bigger than 1. Okay, thank you for watching the video. Have a wonderful weekend and day, ladies and gentlemen, and I'll talk to you next time. Bye-bye. Well, actually, I'll talk to you on Friday, if you have my class on Friday.